love the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. So today in the entire chapter of Python, this is chapter 95. And in the science Python, this is chapter 6 and part 2 of the spatial data and the final part of spatial data. When we saw the spatial data yesterday, I did mention, let's actually stop here, and then in the tomorrow's lecture, we'll be covering everything about distance. So now we know what the spatial data is and how we actually go by it. All right. So today we'll be seeing about all the distances in the spatial data. So what is a distance matrix? There are many distance matrix used to find various types of distances between 2 points. So this is point 1 and this is point 2. If you want to find the distance, this is called the distance. All right. So it can be an Euclidean distance, cosine distance, etc. Okay, the distance between two vectors may not only be the length of the straight line between them, it can also be the angle. So it can also be the angle between them and the number of unit of steps required. It's not necessarily only the length, it can also be the angle between them and stuff of that nature. So many of the machine learning algorithms so basically provides the performance depends greatly on the distance matrix. That is the k nearest neighbor, or k means, like, if you want to find algorithm, if you want to find the optimization, you would always go for the nearest path, or this is called optimizing, right? So if this is a, this is b, the cost of computing from here to here is more. So whereas, like, if you actually find the shortest distance where you can cover the entire length, that is super, and that is the machine learning. All right, so let's actually have a look into the different distances, and the first thing is the Euclidean distance. So the Euclidean distance between the given points is, we actually take this. So this is how we actually find the Euclidean distance. So the code is the same from SciPy spatial data distance import Euclidean. We have P1, two vectors, and then I say find me the resolution of this, and then I say print this. So when I actually give this, it gives me the distance. So 9.21. So 9.222. It actually gives me the distance. Next one is a city block distance, the Manhattan distance, also called as a Manhattan distance. Is the distance computed using 4 degrees of movement. I don't know why it is called Manhattan. I don't know why it is called city block. Nor do I know. I mean, I think it's the name of a person, but this I really don't know. So, but this is called a 4 degrees of movement. That is, we can only move up. We can only move up, down, right, or left, but not diagonally. So maybe that is why it is Manhattan. You can only move up, down, right, or left, but not diagonally, but not like this. So that is why it is called Manhattan. So if you want to actually see this, and if you want to actually take this, so this is also called as a city block, right? So if I actually take here, I import Euclidean. Here I import the city block, and in the Euclidean I have a city block, and then I do a print resolution. I have 11. All right. So next is the cosine. So the cosine, sine, tan, we might have actually heard it. So the cosine is differential angle. So this is the angle between 2 points A and B. Okay. So if I have this, and then if I do spatial, so this is a distance. So this is the distance, import cosine, P1 1 comma 0 10 comma 2 resolution cosine P1 comma P2, and this is this. So if I actually run this, I have 0.012, so 0.02. All right. So next is called the Hamming distance. I've heard of a Hamming word, but I don't know what a Hamming distance is. So it's a proportion of bits where 2 bits are different. It's a way to measure distance of binary sequence. As I said, the Hamming is the way to measure the distance between the binary sequence. So here it is, binary is always zeros and ones, right? So true or false, right? So I have this. So the same, the distance import cosine, distance import Hamming. I have true, false, true, false, true, true. I have Hamming P1 comma P2. I have resolution. So when I actually do that, it actually gives me 0.67. So these are the different distance which is actually available. Euclidean, Hamming, cosine, Manhattan, city block or Manhattan, and then yeah, that is all. So this actually concludes the spatial data. I trust you have actually watched my lecture, probably understood it, probably enjoyed it. If you have any questions, kindly contact me. I'll actually try to help you to the best of my abilities. Like always, I'd like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree following me to follow my passion. Till we see next time, thank you, take care, and cheers.